Alright guys, welcome back. So today we're gonna deal with a new problem. It's still an easy problem. It's problem 292, is subsequence. So let's have a look at this problem. So given two strings, s and t, we want to return true if s is a subsequence of t, or false otherwise. Okay, so let's see what a subsequence is. A subsequence of a string is a new string that is formed from the original string by deleting some, can be none, of the characters without disturbing the relative positions of the remaining characters. So ACE is a subsequence of A, B, C, D, E, while A, E, C is not. Okay, so basically a substring is just some letters taken from a bigger string. You may remove some characters, but the characters inside the string should not be moved. Okay, so for example, hello is a substring of the word HRR hello. Okay, but hello is not a substring of the word not a substring of the word like LOH. So basically you are moving a letter, so this is LOH1. Okay, so this is not a substring. Okay, this is as far as I understand. Now I want to see first if we, okay, yeah, exactly. S and T consists only of lowercase English letters, so no numbers. So let's write QWV just to have an example. So given these two strings, we want to see if S is a subsequence of T. Fair. So let's look at the example. ABC is a substring of AHBGDC. Yes, it's true. AXC is a substring of AHBGDC. False, of course, because there is the X missing. Okay, great. So what I'm thinking now is just we can have a substring S, and then we scan each letter of S, and then we look if S is in T. So we have a double for loop for each letter in S. We check if the letter is in T. Of course, we also want to keep the order. What does this mean? It means that if I find a letter in S that is actually in T, but the previous letter in S was in T and it was later in terms of how the characters are positioned, then of course this invalidates my attempt, and so we may wish to return. So we have to return false. So it feels like we need two counters. So let me follow this idea. So on one side we do a for loop, and so we say for letter in S, okay, which is our subsequence, and then for each letter we actually scan T. But we initialize a new counter, which is no, let's not call it T, of course, let's call it index. So we initialize index at 0, and so we say for character in range, and this is it. So we want to define n as the length of T, and then we say that for every character that goes from index to n, so you see what I'm doing, we want to check if letter is equal car, and if it is, we update index to T car. +1. Now, of course, here car is not the right way to write it down. For I in range index n, we see if letter is equal to t of I. Okay, and we reinitialize the index to I. Okay, I plus 1. So let me explain why I'm writing this down. So I start with an index of 0, and then I go through all the letters in S. Then what I do is, the first time I just look at all the range. So I have my range from 0 to n, so I'm basically looking at every letter, at every character in T. But then if I find the first letter which is actually equal to in T, that is equal to the one I'm looking at in S, and if so, now I want to look only at the letters that go after my previous letter, okay, because I want to keep the order in S, okay, and then in the end, and then the first thing that comes to my mind is that I simply increase a count of 1, then I initialize another variable count, and then if in the end, if count is equal to the length of S, then I return true. Otherwise, actually, if the count, as I expect, is less than the length of S, I return false. I want to see if for any mistake we return none, which means that our count is greater than the length of S, which actually should be impossible. Of course, this means that I should write down break after this if statement, because the first letter we find should be the last in this for loop. Okay, let's try to see what happens. Wow, accepted. Okay, this is fantastic. Let's try to submit. I expect this not to be the optimal solution, and wow, also bits 100%, crazy. But this is not great, because we actually have in worst case scenario, we have a complexity of, let's call m the length of S, so we have a complexity of n times m. Yeah, we have a complexity of n times m. So let's see the follow-up. I suppose that there are lots of incoming S, say S1, S2, S key, and you want to check one by one to see if TS is subsequence. In this scenario, how would you change your code? So we have a bunch of subsequences. I would like first to see if there is any way to make this algorithm more efficient. I don't know if there is any more efficient solution. But of course, we need to scan in every letter in S and every letter in T, I guess. So yeah, maybe this is the best solution possible in terms of time complexity. I don't know if it is actually possible to increase it, to do better. So at this point, I will go and have a look if there is any other better solution, and I will come back to tell you. Okay, so I had a look, and we can do that. Of course, since we are dealing with the category 2 pointers, we can do that with 2 pointers. We actually had 2 pointers here, because our 2 pointers are, in a sense, our I and our letter. But what we can do, a way we can do that, but better, is to simply say, let's forget about everything. So we know that our solution works, but just because we want to be super good in understanding these algorithms, what we could do instead is to write down I and write down J and initialize both to 0, and then write down something like while our I is less than the length of S, or our J is less than the length of T. well, actually not or, actually and, okay, because we want both conditions to be satisfied, then what we look at is to simply, the idea is we take the two strings and we check if the two letters are identical. So let's say si equal to tj. If those two values are the same, we increase I by 1 and we increase j by 1. Okay, but in any case, we increase j by 1. So if it is not true, actually, okay, we can do this. We always increase j by 1. So either if si is equal to tj or not, and should be it actually, because once we go outside from the while loop, then we can simply return I equal to the length of s, because if I is identical to the length of s, then we won. If it's lower, then we lost. Sorry guys, I have to authenticate again. Okay, I'm back, so let's try now. So this gets accepted, and let's see if I submit. It gets accepted too. Okay, so what did we learn again from this algorithm? Again, a while loop is very useful because we have two pointers and we are increasing both. And of course, if we end up in increasing I until we get to the length of s, then we won, because we found that si is identical to tj for all the letters in s. So thank you very much guys for joining me in this video. It was very nice, and see you in the next episode.